So this one here, I was pretty amazed at, although you do have to spend more than an hour to make it good. But in this one here, somebody made a whole bunch of images and then deliberately blurred them. And tried different cameras and made blurry and sharp images of real photographic images. So I took a smaller subset of them again and put it on my website just so we can have a smaller data set to work with. So I import these images and then process them so we can use them. And here's what they look like. This is a sharp image of like a chandelier and then a blurry image of it. So you see they're full color images like you get with a camera. And so we split it into training and testing portions as usual here. 20% of them are the testing images and the others are the training images. And then we prepare an encoder which will encode these things. I don't completely understand exactly what it's doing. And then we prepare the model. Like the last one, you've got encoder input, 3 colors, 128 by 128 pixels, and then there's going to be numbers in there going from 0 to 255 for the 3 color values for each pixel. Then you're going to have several hidden layers, I think, here doing the calculation, and then an output layer. So here's the decoder, because in this case the output is going to be another whole image. We're not just going to be sorting it into 2 or 10 categories. We're going to have an output image that's just as big as the input image. So you have a decoder at the end, and so that has 17 million parameters for the input and 17 million parameters for the output, to end up with another 3 colors, 128 by 128 pixels. So you can train the model. Now if you train the model on just 5 epochs, which is what this does, 5 epochs of training with a total of 34 million parameters, then it runs, and if you look at the results, they are horrible. 5 cycles of training is not enough at all. Now it takes this blurry image, this is the sharp image it should be, and the model outputs that, which is horrible. So this is completely useless, worse than useless. It makes it worse, but the problem is just not enough training. You have to train it for 100 epochs, which will take more than an hour in a Google Colab instance, but they let you do it. And if you do that, it actually starts working. See, here's the blurry image, here's the sharp image, and as you can see, this has got some of the blur out of it. It's moved it in some direction, and this is a standard I see on TV shows. They have like an image, a surveillance video of like a car, and your license plate is blurry, and they say, sharpen that, and magically it sharpens. And here we are doing that, magically sharpening with AI. You can actually do it to some extent. So anyway, like here, for example, it's just what I was thinking of. These are books, and you can't read them. I guess they're not books. I guess it's just a hamper. It looks like a book. But anyway, it's blurry, getting a lot sharper. If we had one of these that had a book cover, we might be able to show how, like this container of bleach or something. I can't read the label, but I can't read it in the sharp image either. Anyway, it'd be kind of nice to have like a license plate you can't read and show it turning to a license plate you can read. Anyway, that's the game here. So there's various things to do there, and it shows, even with these free Google Colab instances, you can actually do real sort of magical processing. Anyway, that's all I wanted to show you. I'm going to stop this one.